All right. Well, we might as well go ahead and get started. That way we can move along. So what we're going to do is we're going to kind of fix this up a little bit. Let's get these guys out of here because something I kind of didn't think about adding, but I want to make sure I throw in is the ability to put in a terminating resistor on the between the A and B lines. So with communication systems networks like RS-485, CAN, uh, the first and last node in one of those buses are supposed to be terminated uh, to help reduce signal reflections, help boost the signal, clean up noise, etc., etc., etc. So I want to make sure that this device can be terminated if necessary. So we're going to go select a 120 ohm resistor if Mauser wants to work, right? Come on. Come on, buddy. Let's go. All right. Oh, lovely. Lovely. Okay. So, since Mauser seems to want to be asleep at the wheel, we'll just go to DigiKey. We'll find a resistor because chances are its counterpart will be, um, yeah, relatively the same price on Mauser. I don't want to hold anything up. So for this, we'll go ahead and choose an 805, 0805 package. Let's see here. 0805. Let's go here. Resistance. So we're going to go to. Where'd you go? Oh, come on. Stop doing that to me. Ugh. Did you keep. Mauser wants to flake out at me, and now you want to do this. Oh, please. Oh my gosh. Ohms. Milliohms. Oh, this is getting entertaining. Let's just clear that. Now let's just apply that, get that out of the way. Maybe it'll be. There we go. 120 ohms. Bam. Has Mauser come back yet? Have you woken up? We also want to make sure we choose active because you can accidentally find resistors that are um, out of production, and that would get to be a royal pain in the behind. Let's see here, stack pole, TE, TE, KOA, stack pole, KOA. Any one of these would be a good resistor. Let's see, 39,000, 66,000. All right. 23,000. So it looks like stock on these resistors are going to be okay. It's not something we have to really worry about. So let's go ahead and just grab this Panasonic. Oh yeah, Mauser still wants to be down. It's fine. We'll just add these guys to add DigiKey to one of our vendors. It's fine. So we need to go into the symbol because it's going to be an 0805. And I think we've got a resistor. No, we don't have a resistor 0805. Boy, it's going to be loads of fun. Loads of fun. Let's see if we can get Mauser back. Because downloading from them, as far as their footprints are concerned, it's a lot easier. Because I think their models here. Let's see, downloads format. What if we do? KiCad. Oh, yeah, here we go. All right. Okay. So notice it downloaded two files and had to, because one actually contains the um, uh, step file typically. There's a symbol. So why did it download it twice? Okay, odd. So it went ahead and give us a step file too. Okay, a little bit confusing. We just need to do the footprint, so let's go and pull that in. Let's get that done real quick first. We're going to file, we're going to import footprint. We're going to pull it from the original file, model. All right. Save it. We're going to go res 0805. Yep. Okay. Okay. I'm also seeing some inconsistencies in some of these footprints, like how that's got a dot, how that guy doesn't. Okay. So what we want to do is we want to kind of create some kind of universal. So yeah, capacitors are like that, except for that guy and that guy. Okay, so let's kind of get some kind of universal standard going on here, because this is not it'll just be a mix match hodgepodge all over the board. So basically we want to kind of set something up for how we want it to look when we for the silk screen, to help orient the capacitors and resistors when they're on the board for pick and place operations, especially if you've got a couple of them next to each other and their spacing could be, either or. If you have a resistor or capacitor above or below, where your pads could be vertical or horizontally aligned, it may be too ambiguous. So we want to kind of come up with a standard way. That way, they all look the same. Let's get rid of that. Get rid of that. So a lot of the caps are using the center, so we'll just go ahead and do that for all of them. All right, let's see here. I think that is that the snap. Yeah, that should be the snap. All right, so let's draw a line, a vertical line. Actually, what we might be able to do, let's copy. All right, so not the prettiest. So let's, what are we at here? 0.127. All right, so let's get our start and our end. Let's see here. Point. Let's see here. Negative. Hey now. All right. All right. Let's copy that. Point, -0.4. Hello. Oh. Um, 0.4. All right. Okay, before we get too far ahead of ourselves, let's go and throw in the 3D model. Go ahead. Open. Okay, let's fix it. Looks like it needs to. Let's try throw in the other one. All right, same thing. All right, okay. Let's try to figure out what we have to go. We have to. Scales fine, rotation all set. Let's see. Still does not look right, but that's fine. Looks a little small to be an 0805 resistor, but we'll live with it. It's just going to be a generic 3D representation. All right, that'll be fine. That'll work. All right, so we have the resistor 0805, 603, 1210, 1206. Go ahead and save that. -4. All right, so we've got the resistor 0805 in there. RC. So what we're going to do is copy this guy. We're going to duplicate it. We're going to go through and fix it here. We're going to rename it. Okay, so it's an 0805. 5. Okay, get the specs. It's 3-digit code is going to be 121. 121. What's your voltage? You're not going to tell me what your voltage is, are you? All right. This is why it's a little easier with Mauser, to be honest. All right. Good. Looks like the part numbers, they're back. The way they do things just makes it a little easier for me to get the data. So it's 150 volts. That made life a little, that's what I was trying to do. So it's 150 volts. So it's 150. And power rating. So let's see here. It's 125 milliwatts, so this can be AAB. Should we have a code? AAB. B. Okay. We're going to go File, Properties. All right. We're going to get that to proper footprint. 0805. Clean up this. It's 150 volts. Our tolerance was 5%, negative 55 to 155. Right? Yeah. And is it a Q200 part? Yep, automotive grade. So we'll just leave that alone. All right, and I think that was a Panasonic as well. Yes, sir. Here's manufacturer part number. Vendor Mauser part number. All right, so 10 cents and 013. Yes, make sure we have that right, or else we'll be ordering the wrong resistor. S, we're going to save that. We'll clean all this up when we get there. So what we're going to do is we're going to do something like this. Now, what we're going to want is a way to enable it. We don't want to have the resistor always in place, because too many resistors in parallel will effectively keep reducing the resistance, and you'll eventually short out the bus. So I'm going to be able to basically enable and disable this resistor easily, because it doesn't have to be done all the time. We don't have to be fancy. So I'm thinking we just go use something like a standard breakaway header. So that is going to be on connectors. It's going to be headers and wire housings, breakaway. We'll do 2 position, 1 row, standard 2.54 millimeter because they're easy. We'll go through hole because they're typically cheaper, and we're already going to have through hole parts on here, so it won't really make a difference. We want them basically to be straight. We're really going to to be honestly on this, let's go ahead and do straight. That way it filters out any of the right angle. And honestly, let's look for the lowest cost. And here we go. We have a Molex, 10 cents a pop. And that's perfectly fine. All right, Molex, 10 cents. And for what it's for, we don't need anything too fancy. This is more than enough. Let's just make sure that it's a 2-position, 2.54 millimeter, 1 row, through hole, pen. All right, 8.32 inch. Okay, that's fine. Let's go ahead and download these guys. Get these guys pulled in there. All right. Extract all. Okay. All right. So, and you know what I forgot to do, and I don't want to get ahead of myself too much because it's gonna make life a lot harder if I don't do it now. Hey. So So we need to make sure we add this to Odo. Only because it just stays consistent and it keeps us up to date with what we're doing. I don't want to get ahead of myself and uh, rush through everything. And that's going to be resistors. Reference is this guy right here. Purchase Mauser. $0.10 for one. Okay. Bump. Alright, so now that's been added to Odo. Much easier. That way we can create our bill of materials later down the road. Now let's go back to where we were. So one of the things I had mentioned was 3 separate library files. One for raw components, for your basic components, resistors, capacitors, everything else in between. One for connectors, just to help organize things, and then one will be, that you could create for a logo file. Like I said, we'll do some kind of generic logo file and show you how we can do that. So let's go ahead and let's see here. New footprint. See if we can create a new footprint library. It's gonna be a global. All right. So files, CAD library. It's going to be, we're going to call it connectors. So we're going to be in the connectors library. And we're going to file, import footprint, downloads. All right. All right. So it's going to be in here. So this is a standard 2x1 header, 2.54 millimeter. So it's going to be a 2-pin by 1 row header at 2.54 millimeter. It's going to be in the connectors library. Bam. So we got that in the connectors library. Now let's see if we can throw in just the generic hello. Come on. There we go. Okay. Rotation. Okay. Get my orientation right here. And offset. Point. 0.2. A little easier to look at the bottom. 1.25. You know what? That is fine. Save that. So now we're going to go into the components. We're going to cancel out that. All right, so we're going to minimize that. We're going to file, new library. We got global library. Public files, KiCad. It's going to be connectors. So now we're going to go and import that symbol, even though we don't have to. Import symbol, just because it'll be a little bit easier. Downloads. Alright, let's get here. KiCad. Yeah. So we want to kind of give this a new name. So I'm going to KH connector header. Just easier when you're searching for this stuff. So if you're just looking through a huge pool of connectors, you can just go KH and there's your connector header. I also use KP for connector plug. This is something I've been doing. All right, so we're going to get that. Leave those alone. We're going to simple properties. Leave the value alone. That's the internal part number. Let's get rid of that. Oh, okay. Oh, there we go. So it's got connected there. Let's get that out of the way. Okay, so let's see about how we're gonna. Okay. Header 2 pin 1 row vertical through hole. Let's go over to here. 2.54 millimeter pitch. Pitch. So we could throw in its post length. So that's what we're going to do, 8.13 post length. All right, now let's get at other specs. It's temperature range, -40 to 80. All right, okay. Manufacturer 1, and I think it was Molex. Yeah. Grab this while we're here. Molex. All right. Part number. Now's All right, get our fender. All right, let's grab all of these guys here. 10 cents and 071. All right, and their part number. And we're going to do the same for Odo. Sales. Go ahead and add Mauser. $0.10. General information. Category. We're just going to create one called connectors. And it's going to be under goods. And reference. Copy that. Paste that there. Save it. Okay, out of that. Save this. Okay, so what that'll do is it'll allow us to use a jumper. So eventually, as we go along, we'll find jumpers, add them to the bill of materials down the road. Something that we know we need to add in as far as a purchasable product that's got to go with this. But for now, we'll worry about that later because it's not going to hurt us too much. All right. Did I not save something? Because that's usually what happens. All right. All right. So it should be. So here's components. Why isn't... I think I need to add the... Yes, I do need to. Okay. All right. Simple libraries. Yes. We have to add that. Connectors. Okay. Let's get rid of that empty line. We're going to okay. Save it, and now we should be able to... There we go. Okay. There we are. There we go. Okay. So what we're going to do is we're going to kind of not the cleanest, not the neatest solution. All right. All right. That will be B up here. A right here. Grab that guy. Kind of clean this guy up a little bit right here. All right. So now we can throw in our terminating resistor with a simple jumper. Easy peasy. And then I'd say the RS-485 right now is complete and ready to move on to the next step. So let's go back to our root hierarchy structure. Go here. So we got RS45. We have our inputs to do, and then our stepper motor control. Need to throw that in here. So be really quick, and it'd be much easier to do our inputs and limit switches and stuff because they're going to be pretty much duplicate circuits. All right, so let's go to KiCad. Go to the schematic here. So we have 3 inputs, 3 limits. Okay. Now let's, all right. So it's gonna be 6 identical circuits. Let's kind of do something a little bit easier. We're gonna divide these 6 identical circuits between 2 schematic sheets because it will be easier for us in the long run. So let's go back to here. We're going to throw in another hierarchical sheet. Okay, we're going to call it switches. And before we get too far, what? Projects. Let's rename. Let's just copy that. Makes our lives a little bit easier. We're going to come back here. Okay, we're going to call that limit. Make sure, because I think we can use spaces. Let me make sure. Yeah. Those are limit switches. And let's go and throw the other one in here. Control inputs. Control inputs. That way, go ahead and create the schematics for us, and we can start. Copy that. Let's go to limit switches. Limit switches. Save that. Go here. Might as well put that in here too. Control inputs. All right, there we go. So let's start with the limit switches. So what I want to be able to do is set these up in a way that we can even interface this device with a PLC if we so choose to. At least basic, on-off controls. Basically, it was just a separate motor driver that's already set up for a specific speed, where we just basically say, hey, you start or you stop. So we're going to have it, and we're going to have a common. That way we can tie our units, our inputs, outputs to that. So what we're going to do is, the first thing we need to do is right here. So we're going to go copy this guy. All right. Go here, because we know we're going to need to add that. So I really like using these fellas. They're AC input. basically optocouplers. I've been using these for a while in my own designs, and they work phenomenally well. They're a good small package, and I see no reason not to use them. So we're just gonna go ahead and throw them in. Let's go and get the go get the CAD models. All right. All right. Extract all. Bam. All right. So let's get into our. I like doing the footprint first. So let's go. File. Import footprint. TCMT. KiCad. Now, before we save this as any guy, let's see if this is what footprint this is considered as. So it might be just a custom footprint for their product. Let's look at their data sheet real quick. Sometimes they'll say if it's a standard footprint. For pin. I even make a quad channel, which could be usable. While I could use a quad channel, I prefer the individual. It's just easier to fix. If there's a damaged one, you only have to replace the one. You don't have to, replace a quad channel. All right. So chances are this is a proprietary package to them. So what we're going to do is go back here. We're going to go ahead and what I like to do is kind of name the packages after the part they're for, just in case. That way it's also easier to find in the long run. I probably could have hit that and found it. Wow. These guys have been let's see here. So I need to 90. That is so odd that the 3D representation has the legs off, but the real product isn't. Again, this is just for um, just for 1.2. It's just to help if you ever have to export a 3D version of the board with the components on it for testing enclosures, like the step file. It's just a lot easier to go ahead and have it that way. So there's that guy. So now we're going to go ahead. We're just going to go ahead and import the symbol. One of these days I should really go through and clean up my downloads folder. Make it a lot easier for me. All right. I don't want you in the connectors. I don't want you in there. Delete. Yes. Maybe I need to go up here. Okay, I have to remember that. Okay. Alright. So we're going to go ahead and rename that. I'm just saying Q because it's technically a transistor. Okay. Might as well save that. We're going to go to properties. Alright. We're going to give you the right footprint. Bam. Okay. All right. Description. All right. Let's go through. And this was Vichet, and there's their part number. Part number. We're going to go to A now. Vendor. Mausa. Low volume. High volume. Grab this guy. 76 cents and 303. And we're going to go ahead and add val, even though it's not going to have anything there. We don't need it. Okay. More of the same. Into Odo. You go. Alright, it's good. I say 76 cents. Yeah. And we don't have one. Technically, that's going to be a transistor. Technically, it falls as a diode, as an LED and a transistor, but we'll just go in transistors. Okay, parent category is good. All right, so description. Transistor output opto isolator. All right. AC input. AC input. NPN. NPN. Let's go here. NPN. Transistor output. AC input. 60 milliamps. Forward current. And that's for the LED side, the diode side. All right, negative 40 to 100 C. All right. Okay. We'll just throw that in here. All right. Purchase. Mauser. 76 cents. All right. 1.0 per unit. Upload. Good. Now that is in Mauser. Or in Odo. My bad. Save this guy. Now, let's make sure there's nothing we... Hey, move out. Stop. Stop. There we go. Let's get these guys dragged out of the way so we can... Okay, 1 and 2. Anode, cathode. That'd be a collector and emitter. So a lot of times the cathode will be indicated as K. Collector there. Anode, cathode, so that's your input side. And then this is your transistor side. There. Clean, easy breezy, nice to go. All right. So we got that there. Let's go here. Limit switches. Components. Okay. So that's our limit switch. And I know there's also a bunch of things I forgot to plumb up on the ESP32 that we'll take care of. Because we do need a pull up on the boot mode pin, and we'll take care of that. We might have to rearrange one of our outputs. If it's an output, it'd be fine. If it's an input, we'll have to take care of that. We'll have to rearrange it. But we'll get to that. I think it's on IO. I can't remember. I think it's IO 0. I guess the mode pin. So we might have to kind of flip the RX and TX, which would be fine, perfectly fine. Or no, we don't want to do that because we're going to be pulling it up. We will maybe the step fault. We'll have to look, see if we can pull that up. We'll figure it out as we go. I actually completely forgot to plumb that in, but we'll take care of that because we're going to have to throw in the UART, USB to UART bridge chip and plumb up the auto programming mode. But we'll do that, and we'll do that later. We'll go through and fix all this and correct all of it. Good thing is nothing's set in stone. We can take care of it as we need to. So we go back to our limit switches. So this will be the input side, the control side. So we'll either have buttons or switches or PLC control. So now we'll want to have a common. Since it's AC input, it won't matter. So if you common it to positive or negative, it'll still work. But one of the things we're going to want to do is we're going to need a current limiting resistor in here to protect those LEDs. You don't want a straight connection to 24 volts DC. So we're going to come back to our favorite place and get a resistor. So SMD chip resistors. Okay, their site seems to be working. So I've got a value that I already use, 1.2 K ohms. And I'm going to use a pretty good size package, like a 1210 for power dissipation. All right, so Yagio, a 1210 package, 1.2 k ohms, half watt. Why do I do that? I just can click here. All right. Do I have a 1210 already in non-resistor? Oh, wait a minute. That's 12 cents. We can find a better price. Plus, I want to make it easier to throw in. Oh, yeah, stock quantities. I want to make sure we have it easier to order too. 10,000, 8,000, 4,000, 7,000, 8,000. Okay, so that's something you have to pay attention to. Things like this. On parts not recommended for new designs, which means they plan on obsoleting that specific part. Uh, Fortunately, there is 1,000 other drop-in replacements. So 1.2K, that's a 1%. That's not bad at all. I just want one that has a 3D CAD model that we can easily download real fast. And then we'll go ahead and here we go. Grab that guy because we mainly need the footprint. Snag that guy. Downloads. But we'll go back to the Yagio because the price is a little bit better. All right, so what we're going to do is, as always, we're going to go through and throw in our footprint for that resistor 1210 package. So here, components, we're going to go file, import footprint. I gotta really clean these up. KiCad, boom. All right. Components. Now we're going to go here. We're going to all right. This has been kind of odd because up until now it's been pretty much placing these guys perfectly on the. Let's see. There we go. Yeah, like I said, it's just a 3D representation. 6. Doesn't have to be perfect, but that'll work. Okay, our 1210 resistor package is set up. Let's get back into here. Just to make things a little bit easier on here, we're just going to duplicate this. Duplicate. Okay, I hit the wrong button. Rename. See, it's 1210. All right, it should be a 1K2, 1.2K, 1K2. What's our voltage? 200 volts. And our tolerance is 5%. Let's see if we already have that resistor. Okay, we're not looking at the tolerance, we're looking at the power. Okay. Alright, power rating. 500 milliwatts. No, we do not. AAC. AC. Okay, let's copy that because let's go through File, Properties, and that's going to be a 1210. Short-term memory 6, 200 volts. 5%, 55, 155. Is this an automotive standard? Yes, it is. So we'll just leave that alone. And it's going to be a Yagio. So let's copy this guy. All right, Mauser is going to be the primary supplier. So let's copy this. 12 cents and 041. Copy that there, and it's going to be 1.2K. All right, so we've got that in there. So again, right back to where we were. We've got to add it to Odo. Lather, rinse, repeat. Again, this is what it takes to do this stuff. It's not all just let's design. We're trying to keep track of everything. It's just going to take some time. Okay. 1. And what was the price? 12 cents. 12 cents. And we'll go here. So it's a good bump, bump, bump. Category is going to be resistors. And the reference, as always, is going to be that fella. Upload. Bam. So now it's an Odo. It's in KiCad. We can go and edit to our schematic once we know we saved it. And we didn't. All right. So bam. So it's a KiCad. It's an Odo. It's here. So we're going to go ahead and do it here. It's RC1210. So what we're going to do, it really doesn't matter what side we sit this on. So we're going to need, so we'll probably end up putting another page in here for connectors, or ancillary, but I might not actually have to because there's plenty of room on here. So let's kind of finish out this guy. So the cathode is actually going to be connected to and give you a net label. We're gonna say this is limit C for limit common. Still not used to having to do it that way, so let's move that in here. Boom. All right, so we have limit common. Okay. So on the other side is going to go to is going to activate the phototransistor. So the collector, we're just going to go ahead and tie to 3v3. And then the emitter we are going to throw a port in here. Let's go. So it's going to be limit underscore 1. Score 1. It's going to be an output. Now, do I have a wrong thing? So what I like to do is throw in a 10k ohm pull down resistor on these. But yeah, that way you have a nice hard pull down on the input. That way you're sure it's that way you can be sure it's not left in an indeterminate state. So what we're going to need to do is our next favorite thing is go back to search results. The good thing is we get to $10k ohms. Case code 0603 is fine because it's low current. It's just going to be a pull down on the input, and it's such a high resistance. 0603 10k ohm. Alright, the Shay is fine. We can go that route. Let's see if there's anything like by I think we'll just go with the Vishay. Yagio, we've got pretty good stock. No, let's go with Yagio. So no 603 resistor. It's fine. 10k. All right. So what we're gonna do is components, and here we go. All right, we're gonna duplicate this, and we're gonna rename it. All right, 0603, 368. So it's going to be 10k. Also, that would be what 106, I think. Yeah, I think it'd be 106. We'll just leave it at 10k. That's fine. 10k. What's our voltage on this guy? 75 volts. And our tolerance is 1/10 watt AAA. Properties. Yeah. It's going to be a 10k. 75 volts. What's our tolerance? 0.5%. 55, 155. And it's a Q200. It's automotive standard. It's a Yagio. Yagio. It's going to be a Mauser part. Let's get its part number here. And 11 cents and 031. Get its part number here, and it's going to be 10k. All right, bam, bam, okay. Save it. guy in here. We're going to throw this guy. We're going to throw ground. This way there's a nice hard pull down on that input. That way it's not ambiguous for the microcontroller for the ESP32. And real quick, since this will be easy to do, we're going to kind of go over here. Actually, let's kind of put you over here. Copy and paste. Limit 2. And limit 3. And then when we pick up in our next stream, next video, we'll go and select the connector, kind of figure out what we want to do. That way we just throw it on the schematic sheet and it'll be added to the system. So thank you for watching. Thanks for catching up. I really appreciate it. You have a good evening, and I'll catch you on the next one.